عليكم ورحمة الله. كيفكم؟ إن شاء الله بخير. الليلة حنبدأ. Okay, let me my unmuted. Let me just make sure that I'm unmuted. Okay. So you guys can hear me, right? Yes. Okay. طيب الليلة حتكون عندنا المحاضرة الثالثة من السلسلة بتاعت Internet of Things، إنترنت الأشياء. قبل ما نبدأ المحاضرة I'm just أحذركم من my mood is not I'm not in a good mood today. واحد شوية حزين، صارت له وفاة person في الفاميلي، وبرضو حزين أكتر على الشباب اللي فقدناهم في الأيام اللي فاتت، كلهم شباب من عمرنا أو أصغر، خسروا حياتهم بس عشان إحنا نتمتع بحياة أفضل والبلد تمشي لقدام. فيا ريت ناخد ثانية أو دقيقة من وقتنا بس نترحم عليهم. إن شاء الله يا رب ربنا يتقبلهم قبول حسن ويصلح الحال يعني في السودان وفي كل البلدان العربية، كل العالم برضو. طيب بس أتأكد إنه الناس سامعني كويس. طيب الليلة المحاضرة حتكون عن Microcontrollers Hardware and Software in the IoT systems. أوكي، تكلمنا المحاضرات اللي فاتت عن أصلاً IoT هو شنو، what are the main components of an IoT system. المحاضرة الثانية كانت عن embedded systems, how do we design for embedded systems. تكلمنا عن كل الكومبوننتس حقت ال IoT، بس كان فضل لنا المايكرو كنترولرز اللي هي الفوكس بتاعت المحاضرة الليلة. طيب لما نجي نعمل design ل IoT system we have to take into considerations the hardware and software at the same time. Okay, قلنا ال IoT is not like a desktop when we're designing a software for a desktop, right? يعني من ممكن نجي ننزل ويندوز على الكمبيوتر بتاعنا، الناس الويندوز ما بيخطوا في بالهم الكمبيوتر اللي هينزل عليه الويندوز ده الكابابيلتيز بتاعته شنو، صح؟ لكن this is not the case مع ال IoT. لازم نعرف نحن الكابابيلتيز بتاعت المايكرو كنترولر او المايكرو بروسيسور اللي في السيستم بتاعنا هو شنو، وباقي كل الكومبوننتس اللي باقي في السيستم، نوع السنسورز، الاكشويترز، محتاجين كارنت قدر شنو، باور قدر شنو، الليتنسي الالاود في السيستم بتاعي هي شنو. فهو it's more of an integrated يعني design. I can't think of يعني a better example of an integrated design than the IoT. طيب مثلا if I have this system it looks very simple. Okay, مثلا عندي هنا an LED that's an actuator in my system. مثلا it will light on and off based on the certain parameters that happens or certain signals that comes from the sensors. My sensors are also very simple, which are just buttons. Okay, on and off buttons, 1 and 0. Okay, and this is my development board that has the microcontroller setting at the heart of it. But although it's very simple السيركت دي، لكن ما حقدر اتوقع البرفورمانس بتاعها من غير ما اعرف السوفت وير البروجرامر running on the microcontroller. How is the microcontroller controlling the actuators with sensors, and how is it treating the signals coming from the sensors, and how is it like sending out the output to the actuator. Okay, فمن غير السوفت وير البروجرامر running على المايكروكنترولر I cannot judge on how this circuit is performing. Okay, although أنا عارفة كل component يعني بيعمل شنو كده، لكن السوفت وير is the one that هتشرح لي كيف ال IoT device دي شغالة. Okay, ممكن يكون two IoT systems having the same hardware components، نفس ال connections، بس they perform differently just because the program that runs over the microcontroller is different. Okay, the fact that two IoT systems عندهم نفس ال hardware نفس ال connections doesn't mean that they perform the same. Okay, so يعني ال software part of the IoT is as equally important، مهم بنفس القدر بتاع ال hardware. So the main takeaway from this slide is that IoT hardware and software components must be designed together and thought of together at the same time. قبل ما نمشي للسوفت وير والمايكرو كنترولرز، بس عايزة أقول a few words about other components الموجودة. غالبا لما نجي نعمل ديزاين ل IoT systems الكومبوننتس بتكون coming from different manufacturers. اوكي، مثلا analog devices. تذكروا زمان لما اتكلمنا عن ال IP cores، صح انه قلنا دي circuits عندها يعني تعمل general purpose، مثلا زي analog digital converters، زي مثلا ال phase lock loops. اوكي، ففي شركات معينة عندها intellectual property صنعت الحاجة دي، فانت ممكن بس تجيبها وتحطها في السيستم بتاعك. اوكي، فيعني يعني نادرا او انا يعني سو فار ما حصل عملت لي ديزاين مثلا للسيستم كانت الكومبوننتس كلها جايه من مانيفاكتشر او بروفايدر واحد. اوكي، ف how do I make sure انه الكومبوننتس حقتي دي حتشتغل مع بعض من غير مشاكل؟ اوكي، انه they're gonna communicate مع بعض كويس، ما في مشكله. فالحاجه اللي حتوريني الحاجه دي، لانه انا حجيب فور شور حتحتاجوا تجيبوا components من manufacturers مختلفه، كل واحده فيها مثلا عندها current requirements معينه، عندها physical dimensions حقتها برضو مهمه. اذا انا مثلا بالنسبه لي نسيوم انه الابلكيشن بتاعي ده كان لي ويربل ديفايس، فبالنسبه لي السبيس مهم، رايت؟ فما اقدر اجيب لي حاجه تكون كبيره شديد تكون ما مناسبه لان الواحد مثلا تكون part of a wearable device. فالحاجه اللي بتحدد لي انه الكومبوننت دي مناسبه ولا لا للديزاين ده هي اللي هي الداتا شيت. اوكي، فالناس لازم تتعلم تحاول تقرا الداتا شيت. الداتا شيت ممكن تكون كبيره، ما لازم نقراها كلها، لكن في حاجات معينه لازم نعرفها في الداتا شيت عشان نعرف انه الحاجه دي مناسبه للديزاين بتاعنا ولا لا. اوكي، اشتريها ولا ما اشتريها؟ حتمروا يعني اكيد حترجع عليكم مرات انه حتلقوا روحكم اشتريتوا الكومبوننت بعد ما جات طلعت ما مناسبه، فايتس اوكي. لكن الواحد يحاول يعمل اللي عليه ويشوف يقرا البارامترز بتاعت الداتا شيت قبل ما يطلب الكومبوننت. زمان كان الواحد بيمشي يعني مثلا بيشتري الكومبوننتس دي من محل بتاع الكترونكس، وكان بيكون فيه دول كده كبير بيقوم بيشرح لك انه لا دي كويسه، انت تشرح له الديزاين بتاعك اللي انت عايزه ويقول لك لا اوكي دي كويسه، جيب دي خلي دي كده. يعني زمان اتليست احنا كنا بنعمل مثلا البروجكتس زمان في الاندرجراد يعني. فحسي لا اغلبيه الحاجات هتلقوا نفسكم تطلبوها اونلاين، ف يعني انت المفروض تحدد الحاجه دي مناسبه ولا لا. اوكي، ف you have to read الداتا شيت بتاعت الكومبوننت قبل ما تشتريها. حاجه يعني دي النقاط I want you to focus on الفيزيكال سايز. اوكي، يعني نحاول نجيب اصغر حاجه ممكن تؤدي المهمه. اوكي، فما في داعي للحاجات الكبيره تعمل لنا مشكله في السبيس يعني بتاعنا. الفيزيكال سايز، الفيزيكال دايمنشنز برضو باي ذا مهمه. يعني الدايمنشنز الجو انا مثلا نتكلم عن هنا البينز بتاعتي دي. طيب احنا بنشتغل على بريد بورد، دايما البريد بورد بتكون المساحه بين مذكرين البريد بورد بتاعنا، البريد بورد ما مذكرين وهندله البريد بورد. اوكي، السبيس بين البينز بتاعته half an inch. اوكي، فانا عايزه تكون البينز بتاعت الاي سي اللي هشتريها دي مثلا سواء كانت اي دي سي او وات ايفر تكون مالتيبلز اوف half an inch دي، عشان اذا ما بقت كده هتكون دي مشكله، ما هقدر ادخلها في اوكي ما هقدر ادخلها في البريد بورد، فدي هتعمل لي مشكله. يعني ممكن تكون رهيبه والبرفورمانس بس ما هقدر ادخلها، فهضطر اشوف لي اكسترنال حاجه مثلا اعمل لها سولدرنج او كده، فيكون التعامل معاه فيري بينفول. فدي حاجه برضو مهمه انه تتاكدوا انه، بس مع انهم غالبا يعني they're taking care of this، لكن مرات بيكون الناس دي يعني لما يكون الديزاين ما بروتوتايب، يعني الناس عايزين يعملوا مانيفاكتشرنج، السولدرنج بعد ذاك ما مشكله، بقت السبيس بتاعهم كم ما مشكله. لكن احنا بالنسبه لنا we're prototyping or using breadboards، ف this is important for us. okay. input output pins، الانبوت اوتبوت pins دي برضو من ناحيه الفيزيكال دايمنشن حسي قلناها دي، وبرضو انها تكون enough، يعني ما تكون مثلا البينز بتاعتها شويه شديدا وانا عندي too many connections عايزه اعملها معاها، ف هتعمل لي برضو مشكله انه يكون فيها reasonable amount of input and output pins. الالكتريكال بارامترز دي برضو مهمه شديده، اشوف الاوبريتنج فولتج اند كرنت بتاعتي، مثلا اذا حاجه محتاجه لها very high drive of voltage and current عشان تشتغل، وانا مثلا المايكرو كنترولر بتاعي بيديني 5 فولتس ودي مثلا محتاجه 7 فولتس عشان تشتغل. ممكن طبعا اجيب ترانسفورمر اعمل ستيب اب للفولتج، لكن اذا في حاجه اوريدي بتشتغل على 5 فولتس جيب اللي بتشتغل على 5 فولتس. اوكي، فتراي تو ريديوس، يعني be cheap when you're trying to do IoT. okay, don't get the best the highest performance لا، جيب اقل حاجه ممكن تعمل لك الحاجه الشغل حقك أوكي، وأصغر dimensions يعني الناس تحاول تكون مقتصدة في الموضوع. أوكي، طيب فدي الحاجات اللي المفروض نشوفها لما نشتري، نحاول نطلب components. طيب زي ما قلت الفيزيكال دايمنشنز بوريك هو الفيزيكال دايمنشن حق الاوفرول كم، والبين سبيسنج دي برضه مهمه نشوفها انها multiples of الهاف ان انش بتاعت البريد بورد. اوكي، دي الالكتريكال current والفولتج. اوكي، عشان we want to make sure إنه we are driving it with the right amount of current and voltage. يعني مثلا ما مدينها حاجة أقل من المطلوب، وكمان في نفس الوقت we don't want it to burn, right؟ إذا اديناها current أكتر من المطلوب هتتحرق. ف we want to make sure إحنا we are operating within reasonable range. طيب أكتر حاجة بتتحرق مسكينة يعني في كل ال IoT designs هي ال LED. أوكي، يعني ربنا يسامحنا على كمية ال LED اللي حرقناها في حياتنا، لكن كويس انهم they're cheap يعني، فما مشكله كبيره. فدايما ال LED بتشتغل على current much lower than اللي هو الستاندرد current اللي بيطلع من المايكرو كنترولر، مثلا 5 فولت. اوكي، فاذا انت مثلا فكرت انك تجيب طوالي من ال 5 فولت دي وتاخدها لل LED في لحظتها هتتحرق. اوكي، ف دايما نحن مع ال IoT system هتلقى نفسك بتحتاج تشتري resistors. اوكي، لشنو؟ عشان نقلل الكرنت او ندي الكرنت لل LED الكرنت المناسب. يعني we trying to reduce الكرنت that's drawn directly from a source 5 volts دي. فمثلا اذا انا عندي LED that operates at 5 milliamps، اوكي، عندي 5 volts، فسيمبلي انا محتاجه لي 1k يعني ohms law، محتاجه لي 1k resistors اخدها in series مع ال LED حقتي عشان to make sure انه انا I'm giving it a 5 milliamps current. اوكي، ال LEDs we don't need really to read the data sheet، بس نعرف الكرنت بتاعه قدر شنو. اوكي، يعني كل الكلام dimensions وكلام هذا ما محتاج له في ال LED، لكن في ال ICs لا we don't need to read about dimensions والinput output pins etc. عشان نعرف وين نديه الانبوت فولتج، وين الجراوند بتاعه، وين الديجيتال input output pins etc. اوكي، طيب طبعا how to read resistance، انه how do I know this is 1k this is beyond the scope، لكن يعني حاجة سهلة ممكن تتعلموا براكم how to read the resistor color code. اوكي، نجي ل our focus for today اللي هو microcontrollers. أنا يا جماعة ما شايفة الأسئلة. do we have questions؟ the facilitators do you have questions before I proceed؟ هذا ممكن تردوا علي في الواتساب جروب، لأن أنا I'm on full screen mode على ال اوكي. طيب انا هحاول اشوف الكويشنز. طيب في الكومنتس resources also. لا مش انا I'm not sharing the slides, sorry Pooja. OS is hardware specific. Operating system for IoT devices, yes, is hardware specific. Yes, and if your microcontroller is Arduino, then you're gonna be doing an Arduino IDE اللي هتعمل الديزاين بتاع البروجرام حاجه هيكون Arduino, which is completely different. اذا كان مثلا المايكرو كنترولر بتاعك او المايكرو بروسيسور بتاعك اللي هو راسبيري باي هتكون بتعمل ديزاين في تكتب البروجرام في بايثون. اوكي، هنشوف حسن انه الفرق بين اردوينو والراسبيري باي are not similar. اوكي، طيب does each component has its own specific data? Yes, يعني حتى even the resistor has its own data sheet, but we just don't read them because they're very simple. Thus each component comes with its data sheet. Yes, you can just type the part number of the component. مثلا for example, if we have a micro ATmeg 360 for example, just type ATmeg 360 datasheet on Google and you will get the datasheet. Okay. Okay, great. So I think we can proceed, and then we're gonna have a break later for questions. Okay, so microcontrollers, the heart of the IoT design. Okay, so we can have two different of microcontrollers or microprocessor on the IoT system. Okay, so an example of a microcontroller is the Arduino. Okay, an example of a microprocessor is the Raspberry Pi. Okay, so let's see. Let's look at the characteristics of each and why we should choose one over the other. So the memory and input output for microprocessors are external. Okay, so a microprocessor is simply a mini computer. يعني the Raspberry Pi is simply a mini computer. So the memory of the computer is usually, so we have an external RAM, right? So that's the case with Raspberry Pi. In the microcontroller, it's internal. It's all like integrated within that small chip. The power consumption for microprocessor are high. For microcontroller, is low. The cost is high. So Raspberry Pi costs more than an Arduino. Okay. The power saving features is limited. It's extensive. Storage. Van Neumann and Harvard. So we don't need to worry about that. Instruction set for the microprocessor is larger than the microcontroller. We're going to see that when you design for Arduino, you have a very small set of instructions to choose from. So a microprocessor requires an operating system. So the Raspberry Pi has its own operating system. We're going to look into that as well. The microcontroller does not require an operating system. The clock speed is much faster in microprocessors. The bit size is higher in microprocessors, and since they have an external memory, so it could also be higher. Okay, so usually for applications that are very very small, very simple, doesn't require very high computations running on the IoT device, I could go for a microcontroller. If not, I need something that's more intelligent, that has more processing, faster clock speed, and I'm not very limited within the budget. I could go for a microprocessor. Okay, we talked about development boards before, that we have a microprocessor and some circuitry around it to support the performance or the functionality of the microprocessor. Okay, so I could have either a microcontroller or a microprocessor on the development board with a printed circuit board circuitry, for example, a USB input, so I can communicate to the with the microcontroller or the microprocessor. I could have an ADC built in within the development board. I could have LEDs that are also built in. You know, some development boards come with their own basic sensors, etc. Okay. So those so now we know that the Arduino is a microcontroller and the Raspberry Pi is a single board computer or an SBC. Okay, so hence Raspberry Pi is more powerful computationally than the Arduino Uno, for example. Although Arduinos they have more versions that are they're getting better in terms of computations. So those microcontrollers are not only Arduino, and there are other types. Okay, so we have Arduino Nano, that's much smaller. Particle Photon, Atwood Feather, and the Texas Instrument, they have the Ativa, a microcontroller. Atmeg, I can't believe that I didn't put Atmeg. It's the one that I mostly use. Okay, STM microcontroller, STM32, Node MCU. So all those are examples of microcontrollers. You just need to read the datasheet and see which one fits for your application. So those are the example characteristics. Sorry about the font, but those are the characteristics of the microcontroller that you want to look for and make sure that they match the performance metrics that you have for your design. Okay, so let me start from the end. Low power modes. So at the beginning, when they used to design microcontrollers, no one really worried about low power modes because the things were static. Okay, so the microcontroller will typically be powered from a plug in the wall. Okay, so if the electricity is always there, then why should I care about low power mode? But now with the Wi-Fi and the mobility, ubiquitous computing. So I want to make sure that my IoT device runs on the batteries or whatever it's running on for the longest time possible. Okay. So low power mode is very important. So you want to make sure that your microcontroller that you choose can have this capability. Okay. So when you are not taking any measurement from the sensors, so you put it into sleep mode, so you are reserving the device power. Okay. And especially if we're doing it for monitoring purposes, etc. And we're doing this monitoring, for example, for agricultural monitoring. If I'm monitoring, for example, the level of moisture on the soil, I don't have to do this 24 hours, right? So I could do it, for example, twice a day, 3 times a day, and I put the device to sleep for the most of the time. So like the device would be on sleep mode 98% of its lifetime. So if I don't have a low power capability in this microcontroller, then this is just a waste of battery, right? Also low power mode, some microcontrollers have the power harvesting, energy harvesting capability, where you could tell it that, so it's like we know it comes with a built-in charger, or you can have an external like power module where you harvest the energy from, for example, from the sun or from RF waves, and when enough energy is accumulated, then the device will go on to make the measurement. But this is like in very relaxed measurement requirements, when like there is no specific times where the measurement has to be taken. طيب الخلاصة من الموضوع low power mode إنه take يعني choose an IoT device عندها الكابابيلتي بتاعت إنها تشتغل في مستويات باور منخفضة، وإنه الديفايس تكون على السليب مود إذا ما في measurement هتتاخد. تمام. ال ADC غالبا أغلبية الديفلوبمنت بورس بتجي معاها built-in ADC، فميك sure إنه ال ADC is of good quality. if not you can ما تستعمل ال ADC الموجود في البورد، you get your own one externally وتوصل معاها عن طريق البريد بورد. input output pins we need to make sure إنه المايكرو كنترولر فيه enough input output pins. يعني المايكرو كنترولر ده هو الهارت بتاع ال IoT system, right؟ فهو هيكون موصل مع يعني need connections مثلا للسنسورز either directly or through the ADCs. يكون متوصل مع الأكشويترز either directly or through the ال DACs. اوكي. هيكون مثلا موصل مع الباور موديول. هيكون تاني عنده مثلا إذا بتكلم مثلا مع other ICs مثلا RAMs, storage devices etc. فالمفروض يكون عندي يعني flexibility in terms of number of pins عشان ما يكون الحتة very congested. communication protocol support. طيب ICs talk together via certain communications protocol. يعني مثلا المايكروكنترولر is an IC, right? integrated circuit. عندي مثلا integrated circuit ثانية اللي هي مثلا either ال ADC ولا RAM مثلا. let's say RAM. okay. فعندهم certain protocols بيتكلموا بيها مع بعض. زي مثلا ال UART, I2C, SPI, etc. فأنا إذا عندي other ICs في السيستم بتاعي other than the microcontroller, I need to make sure إنه هم بيتكلموا they speak the same language. okay. فيمكن ما لاحظتوا لا، بس let's go back to the data sheet بتاعت this one. This one is an isolated monitoring analog digital converter. هنا في الداتا sheet they tell me the communication protocol that it speaks. okay. It supports UART, it supports I2C, and it supports SPI. So most likely all the ICs they support the three يعني most widely used communication protocol. فبس you just need to make sure some those microcontrollers they can come from يعني كده infant manufacturers list, they're not aware of everything. فممكن بس يكون عندهم they support only one and the other IC supports only two. فما في matching بيناتهم. just make sure that the communication protocol that في ال ICs that are available in your IoT system كلهم يعني في unified protocol ممكن يتكلموا. ما لازم كلهم يكونوا available. if كلهم بس بيتكلموا UART that's okay. we can all talk UART. we don't need to يعني at the end of the day احنا هنستعمل واحد، ما هنستعملهم الثلاثة. okay. التايمر مثلا for we need it for real time applications إنه at a certain time do this. okay إذا محتاجين عندنا real time applications we need to make sure إنه our microcontroller has a timer. تقريبا كل المايكروكنترولرز عندهم this capability بتاعت التايمر performance حسب أنا how fast do I need the computations to be. okay if performance is key then I might want to go for an SBC, okay, single board computer than microcontroller. okay data bit width, the number of registers or number of bits in each register. so هنا دي اتكلمنا عن الموضوع ده هنا. bit size, okay, bit size like determines the resolution of commutations. يعني مثلا كم أنا ممكن الرقم ممكن how many figures can I present the number with. فإذا مثلا عندي رقم 3.356789 okay do I have the capability to represent a number ولا حيكون مثلا في النهاية اختصره على 2 decimal digits. okay this is this defines the resolution of commutations. فأنا if I want the sensors to be very sensitive وأنا the slightest change in مثلا in light intensity مهم بالنسبة لي I should go for a microcontroller that has a higher bit size. okay the data bit width determines the accuracy and the throughput and the sensitivity of my application. إذا الapplication is very sensitive يعني التغيير البسيط في physical environment مهم بالنسبة لي إنه أعرفه. I want to go for a microcontroller that has a high data bit width. okay طيب we'll take a sample of microcontrollers with Arduino. Arduino is an open source hardware and software company. It's ideal for learning. It's less suited for professional and industrial use. طيب يعني هو mainly معمول للتعليم فدايما تلقوه في اللابات حقت الجامعات أو كده المدارس. now they're using Arduino عشان يعني it's very easy to use. okay السوفت وير بتاعته very simple. okay يعني السوفت وير سوت بتاعه very 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 simple. عنده في كم نوع من الأردوينو. so we have Uno, the one that now we have Duo, we have the Nano. okay they are trying to يعني they're trying to move from a learning or an educational target to more industrial one يعني do more capabilities عشان الناس يستعملوه for their design and prototyping purposes. Another microcontroller ESP8266. The benefit of this one, it comes with Wi-Fi. It has a Wi-Fi capability into it. يعني مع Arduino you need to have your own Wi-Fi. يعني تجيب لك تاني موديول بتاع Wi-Fi تركبه عشان الكوميونيكيشنز مع الجيتواي or اكسترا بدلة ال ESP8266 جاي معاه الواي فاي. هنا شايفينه ده الواي فاي موديول و this is the antenna of the Wi-Fi module by the way. okay يعني الكمبيوتيشن باور بتاعته معقولة to some extent, not great but it's okay يعني for simple applications. This is how the Arduino IDE looks like. okay the programs are called sketches. هنشوف الحاجة دي لما نجي نطبق على Arduino. two functions setup and loop. يعني البروتوكول stack حق الأردوينو it couldn't be simpler. a development life cycle of programming Arduino. First you edit the program, you compile it, okay, you upload it to your microcontroller and then you run it. هنتكلم towards the end of the presentation عن موضوع compilation ده أو how does it differ. طيب other type of microcontroller, it's not a type of a microcontroller but المهم control units that are available in IoT devices, the single board computers, which are most widely used or the most famous one of them is the Raspberry Pi. okay so it's a single board, complete computer built on a single circuit board. so it's it's similar to the PC or laptop بتاعك but it's just smaller. okay it has a microprocessor, a memory, input output, and it has a screen basically. okay so when you see that when you access a Raspberry Pi, it has its own screen with tools, settings, etc., as if you are dealing with a standard computer. okay application areas of single board computers, naturally embedded computer controllers, for robotics, gaming. I know it has more, it's more computationally capable than microcontrollers. Single blade servers could be used, for example, for do they call them? I forgot the word. Is very useful for industrial prototyping and for educational purposes as well. Drones, you can use them for drones. They have any more computational needs. It was originally designed for low-cost teaching tool for computer science people. It has become a popular Linux SPC. It has different modules and dimensions. This is typical specification of Raspberry Pi. That we're gonna use this in one of our labs. Raspbian is the operating system of the Raspberry Pi. So one of the main differences that we saw between single board computers and microcontrollers, that SPCs, they have their own operating system, right? So my laptop has Windows as the operating system. If you're using Mac, you have the Mac, the OS operating system. What was it called? The Mac, I'm not sure. And Raspberry Pi is no less than that, right? So it has Raspbian as its operating system. And the specifications are much better than the Arduino ones or the ESP8266. So this is how Raspberry Pi desktop looks like. So it looks like, doesn't look like any less than a computer. Okay, it's connected to Wi-Fi. It has Bluetooth connection capability, and so it looks like a computer basically. It doesn't have a screen, so you have to connect it to a screen. And this is a Python code that's running for an IoT device. I'm not sure what it does, but this is how a Python code goes. So usually when we do Raspberry Pi, we design with Python. Okay, you run the code in Python, and the Arduino, it has its own Arduino IDE for development. So the last thing I want to say today, so let me get some questions before I go to the software translation. When did we stop last time? So what's the difference between a microprocessor board and an SPC? Okay, so an SPC is a single board computer. Okay, so everything that's included in standard PC is included in SPC. So naturally, we don't have that much space for higher RAMs. Okay, so it functions as a computer, but with lower capabilities. Okay, but everything a computer has, an SPC basically has. The main functionalities are there. Okay, the second question is, any OS is hardware specific, not just IoT? Not really. So, for example, the Mac people, the hardware and software are designed together, right? So they are the same provider of the hardware and the software. So that's why they claim that Mac is much better, because they were designed together. But Windows, on the other case, it runs on any hardware, right? So it could be the microprocessor could be from Intel, it could be from Lenovo or whatever. So the Windows system can run on different hardwares. This is what I meant. But when we do IoT, I cannot say, oh, I'm not sure if I'm going to do this on Arduino or on Raspberry Pi. Let me just no. So if you're doing it on Raspberry Pi, then you know that you have higher computation capabilities, so you can do more with the device. But if it's an Arduino Uno, you're very limited in terms of storage space, computational clock speed, etc. For you, so you better design your hardware based on that, so you don't get very you can get the sensors that are very, that requires, or you don't do application that requires very sensitive measurements, and you don't have the right bit width for that. Okay. Is the program you write on microcontroller considered? No, That's no, the program I write on a microcontroller is not an operating system by any chance. Okay, a microcontroller, I cannot run the program directly into the microcontroller, so I'm gonna have to write this into a development environment on my write it on my laptop, for example. Then I compile it, and then the microcontroller at the end is going to run a machine code. Okay, zeros and ones. So whether depends on the program, whether it's run on C. It was, for example, if my program was on C, then I have to compile, turning into machine code. If it's on Python, then it has to be interpreted before translating to machine code. We're going to talk more about compilation and interpretation in a second. Okay. So you use Arduino. That's great, Pooja. So you have experience with Arduino. Input output, I believe. So someone is asking if there's a محاضرات عن user experience. I mean, I'm not sure. So I'm not sure. You can contact the organizers of the session. What can be done with the microcontrollers with Wi-Fi? So an IoT device, we said the main functions of an IoT device, that it's a thing, right? It has a microcontroller, computation capability, and it has a Wi-Fi connectivity or internet connectivity. So after I get the data from the sensor, etc., so I want to send it to a gateway or to the cloud to do further commutations with it, because the capabilities of the microcontroller are limited, but I can leverage the Wi-Fi and the internet to do more complex computations. So I need to have any IoT device should have connectivity of somehow, whether it was Wi-Fi or any other communication protocol, Bluetooth, whatever. So I can connect to the gateway. I have two levels of connections on IoT. The connection from the IoT device to the gateway, and from the gateway to the internet. Okay. I hope this is clear. Can I define how bits are fed into microcontrollers? Like I have it 32, but I choose to feed them at 8 bits speed. I believe you can do that from the program. You can define how much you are feeding from your data. Yeah, that can be done. Do we need a Raspberry Pi for the next lab? I believe we are using a Raspberry Pi as an edge device. Okay, so I said we have an IoT device, we have an edge or a gateway, and then we have the internet, right? So usually we can use microcontrollers in the small IoT systems, in the device itself, and then we use the edge as a Raspberry Pi because it has more computations, can do more computations, so we can do the more intense computation in the Raspberry Pi rather than the small microcontroller in the IoT device. Is it recommended to use Python for coding on Raspberry Pi? Yes. Is it recommended to use Python for coding on Raspberry Pi? Other languages can be used. They can be used, but we're going to compare Python to other languages in a second. So you can okay. So I think we can go back to the slides. We don't have that much time, but hopefully if we have time towards the end, we're going to talk about your questions some more. Okay. طيب software translation. طيب خلصنا نحن حسي خلصنا من الاي او تي ديفايس، خلصنا من الهاردوير، everything is okay، وكتبنا البروجرام بتاعنا in whatever language, whether it was C, Python, Arduino. Okay. طيب what happens next? How does this program get translated into my بتحول من whatever انا كتبته مثلا على اللابتوب بتاعي، عايزه احوله للمايكرو كنترول عشان to run it, right؟ طيب في الراسبيري باي يو كان تكتب البروجرام على الراسبيري باي نفسه. اوكي، ما محتاج تكتبه somewhere outside and then you compile it to the Raspberry Pi. عكس الاردوينو تكتبه في your laptop and then you transfer it to the Arduino. Okay. Whether it was an Arduino or a Raspberry Pi, whom they are microprocessor microcontrollers, they run machine language, right? Zeros and ones. فأنا محتاجة أحول الهاي ليفل لانجوج اللي أنا unless someone I don't know anyone who programs in machine language. I'm not sure if any human does. zeros and ones basically, right? فأنا بكتب في high level language. نحن بنكتب في high level language they are C, Python, Java, etc. and الكمبيوتر بيتكلم machine language فمحتاجين to compile the code from high level to machine language. طيب في عندنا a middle language between الماشين والhigh level اللي هي assembly language. هي easier to read. You can write in assembly language. It's not hard يعني. Okay. So we used to teach assembly language for third year electrical engineering students. There P Mars, if you are interested to know about assembly language, there is assembly language called Mars. I can give the link for it to the organizers and they can share them with the audience. And it's easier. So it's add, multiply, subtract, those simple mnemonics that represent the machine code. طيب, so which language, what's the difference between these higher level languages? Does it matter if I wrote in Python and C? Does it matter with the microcontroller? Yes, it matters and it differs. Okay, so C use compilation. Okay, so C and C++, they are compiled language. What do I mean by compiled language? That means the instructions or your code is translated into machine code once. Okay, and then each time you run the code, you don't have to compile it again. Okay, let's assume that I wrote my code is okay and it's run properly. I will compile it once, and then each time I use my IoT device, it's just gonna just gonna be executed. It doesn't have to be compiled. On opposite to the Python is an interpreted language. That means, I'm sorry guys about the background noise. That means each time you each time you run Python, the program is going to be interpreted one line at a time. Okay, so at the time execution, the program is going to be interpreted one line at a time. You might think, oh, C and C like seems better in this sense that I don't have to do compilation each time. So the program is just there and it's going to be faster. That's going to be executed, right? But there is one take here. In C, you have to take the pain of declaring your variables. Okay, so because the program is going to be compiled once, so there has to be like the program that is not going to have the leverage to understand what's going on. So you have to explain X is an integer, Y is a float, and sentence is a string. Okay, so you have to allocate memory allocations for those. Okay, and declare their type before you at the beginning of your program. As opposite to Python, الانتربريتر ما لازم تعرف انه اكس كده واي كده، هو براه من خلال تعاملك مع الحاجه في البروجرام حيعرف انه اكس دي شكلها انتجر، اوكي هتعامل معها كده. فدي يعني دي الفائده بتاعت البايثون، انه ما لازم you don't need to declare your variables before using them in the program عكس السي. Naturally, C is faster. A C program runs faster than Python لأنه compilation happens once, where in Python and interpretation happens each time you run the program. Okay. So Python is easier to learn. Okay, so the learning curve is much faster in Python. I said interpreted. Interpreted means it's slow. So C is fast and efficient. It's a general purpose. Learning it is not as easy as Python. Okay, Python has more libraries dedicated towards machine learning, AI, and data science. Okay, so and you can share it in different platforms, notebooks, those type of things. When it comes to IoT, if you are doing a prototype, you are just learning, you might want to do Python. But C is more efficient. Okay, C is more efficient. يعني عشان if you don't want to leave things for the interpreter عشان هو to assign things in your program، انت يعني C gives you more control over your program, how it runs, the speed. يعني the speed غير الموضوع compilation interpretation. You can control your memory allocation better in C. So usually for commercial purposes they use C. Okay, where for education and development, prototyping, you can use Python for that. C more efficient, faster. Python is easier to learn and slower. So it's your choice. I think we're done, so we can take questions. Are IoT bootstrap compiled? What do you mean by IoT? So which type of IoT? What now you need to be specific about which language you're using, what controller, which microcontroller you're using. Thank you. So now I hope this gives you an idea on how to choose. So now you should be able to choose different microcontrollers. Can I share a link with them? So I shared the link with the organizers earlier in the day. If you can share it with the audience, I just want to give them a simple exercise. Okay, so a link has been shared with you in the comments. So I want you to practice how are you gonna decide on a simple component of your IoT system, which is a temperature sensor. Okay. So this is typically how you're going to do things. Okay. After you do the layout of your design, you're going to go to a manufacturer or an IoT components seller and start picking components by one. Okay. So if I tell you that I need a temperature sensor that operates at a maximum voltage of 5 volts and it has a sensitivity of 5 millivolts per centigrade. Okay, that's very sensitive. So each change in 5 millivolts is detected in temperature. And a temperature change of, for example, 1 centigrade is translated into a 5 millivolts change. I hope all of you have went to the website and start looking for temperature sensors. Okay? There are different part numbers. So if someone have managed to find something, they can share with us the part number and see if it qualifies for the requirements I asked for. So I want it operates at maximum voltage of 5. I'm not sharing the screen. Let me, okay. I want you to do it on your own, but I can. I can stop the screen and then share the analog devices. Can you see my analog devices now? Can you see my analog devices page? No, you cannot see it. Okay. Anyway, any my. Okay. Okay, so I hope you just got the point from the exercise. Is to go to, this is how you typically look for components for your IoT. Okay, so you identify what's its temperature sensor. You go and you look for it. It tells you that you find like millions of them. Okay, each of them has its own operating level. You need to make sure the first component, by the way, you choose for your system is the microcontroller. Okay, it will tell you how much power, because the microcontroller typically powers the entire system. Okay, the power comes from the microcontroller itself. So you know how much voltage is available. Okay, the number of pins, the communication protocol that's available. So if you have any other ICs, you make sure that they can communicate properly with your microcontroller, and then from there you go and choose the sensors, you choose the actuators, etc. Okay. if you don't care about speed, you can go for Python. So I suggest that my personal suggestion is that if you don't care about speed, you design in Python. If you have very tight requirements, then you can do C, and good luck with that. Okay. So if we don't have further questions, I think we are okay, right? Okay, guys. So I think we're done for today. Thank you much for coming, and we're gonna have the lab next. So if you have any instructions about the lab, or if you need to prepare anything, I'll share them with the organizers so they can share them with you. Thank you so much, and goodbye.